All right, I think we are live. This is the first time in a long time I've been streaming from the office, so just gonna take a second here to make sure everything's going good as far as our inputs and outputs audio-wise. I can see mic in. Sounds like I didn't mute myself on my own stream, so I'll take care of that real quick. Actually, since I have headphones now, I can actually check my own stream health. So let me try that real quick. See how the audio sounds. Sounds pretty good from my end. I definitely hear background noise. Wonder if I can turn that down at all. Oh, looks like my mic I can apply, my webcam mic I can apply extra settings to, but not my primary mic, which is weird. Check. Okay. Now I unmute it. No auxiliary mic. Then turn on noise suppression. All right. Well, I think it's definitely a lot quieter. Yeah, what was that for a second? Now I can't hear the background humming of everything. Unless I can find what's humming. Is it one of the printers? You know what, that's pretty good. We'll leave it there. I also think since the mic's very close to my mouse right now, you'll be hearing a lot of clicking of the mouse, so I apologize for that. It is what it is, though. Let's see if I can actually take some of this gain down. Oh. That might be all right. Okay, yeah, let's run that. All right, welcome back to Samet Industries, another live stream today. Today, we are Oh, I don't think we'll have live audio like for you guys' chat. So I can see Dragon Heroes in chat. Hello, welcome. So it'll be up to me to read your guys' chat messages out loud or to myself because we're in the office. I don't have all the speakers set up to do that the right way. But I still have chat pulled up so I can see chat. So I'll appreciate messages as always. So today I am working on some of my wiring diagrams and ECU input-output stuff. So I will be running the brand new Speeduino Dropbear V2 ECU for JDMSTIVA V2. It's very nice how V2 and V2 works out like that. I've got it plugged in and running right now over here. Let's see if I can drag it by real quick. There it is. I can't see myself. There I am. Anyway, there it is. It's a pretty compact little unit. It comes in this really tidy water-resistant case, 2 sealed motorsport grade connectors. We've got all powered from a teensy 4.1 or 4.2. It's got inboard map sensor, so you can do all your pressure stuff on board with a vacuum line. It's a nice bit of kit. So this one has 8 channels for both ignition and fuel. So you can have 8 sequential fuel injectors, 8 sequential spark. So full sequential V8 or batch fire of V16, etc. We're only going with 4, so we're running fully sequential 4-cylinder ignition for fuel injectors, which is very nice. The stock Festiva is batch fire, so there's only 2 channels, so it fires 2 injectors at the same time. Every time, we'll have a lot more control this way, firing 1 at a time. And since we're doing coil on plug, we will be using fully sequential firing for the coils, for the coil on plug coils for the cops. So there's our ECU. I have just started figuring out all the initial data for that thing. So I'm getting it set up before we even plug it into the car, before we touch anything. There's a lot of stuff you have to start with settings wise, so I've been going through doing some of that already. A long time ago, I started making my own wiring diagrams with Excel, or in this case, Google Sheets. So you can probably see some of this here. If I zoom out a tick, there's all the pins on the 2 connectors. So there's a big black connector and a big gray connector, their pinouts, and then the general description of what they do here. And then down here, I drew a quick diagram in Photoshop, but I made all this probably 3 years ago, and I have already changed a lot of how I plan on doing this. Before, we were going to have like a slightly modified engine bay harness. We were going to try to merge that with the stock Festiva harness and then run it really simply that way. But now I'm trying to like shave the engine bay, make everything super clean, and I'm building my own wiring harness from the ground up, like entirely brand new harness, all new connectors, all new pins, brand new wire. I'm custom sheathing it, I'm custom wrapping it all, I'm running it through a big bulkhead connector on the firewall. I'm basically going to delete all the stock Festiva harness from the firewall forward. So that means everything, the headlights, all the engine controls, all the body control stuff, all of that I'm going to delete and rerun with brand new wiring because I'm using a different grill that has 4 headlights instead of just stock 2. I'm running different turn signals that I want to have running lights built into. So since there's so many wiring changes I want to make anyway, and half or like 70% of the harness from the firewall forward is for the engine that we're now running our own harness on anyway, there's a ton of dead wires in there that we don't need that we can delete. We can get rid of all the old unsealed relays. I'll be running my own miniature fuse box that has spots for new relays that are smaller. I'm gonna be running that to keep it all tidy. So I've been deleting all the stock relays, all the stock harness. So it's a lot easier in my case just to take it all out and start from the ground up. Now normally I definitely would not recommend this for a B6T swap. In the B6T swap guide, we will not be doing this. We're running the stock harness combined with the stock Capri harness, the stock Capri ECU, etc. But in this case, I have so many cool new things I want to add or try on this build that we basically started from the ground up here. So with that in mind, this little diagram here that I drew a long time ago in Photoshop is out, and now I'm trying to make a much more professional diagram, and I'm doing that in Illustrator currently. So I will pull that up real quick. Wrong monitor. Zoop. Put that over here. All right. Turn off the grid view for a second. So this is what I've got so far. This is my hand-drawn wiring diagram that I've made in Illustrator. Basically, we're starting off with our ECU, which I said we have those 2 connectors, gray and black, and then the basic description of what they all do in a chart here for each pin. And then it's laid out very similar to the factory Festiva wiring diagrams, where we have everything from each connector branched out going to each device that we need to power up or give signal to from the ECU or to the ECU. And since we are running our own drive-by-wire throttle system now, instead of using a throttle cable, that's a whole other bucket of worms we have to open for that. So we have to have a custom throttle pedal with a new sensor on it. We have to have a controller just for the drive-by-wire motor on the engine side. And then we have to have the drive-by-wire motor itself on the engine. And each of those has a ton of its own pins, its own tuning that needs to be done. So I had those already done. I got that wired up. So basically we have our throttle controller here, which is coming from LD Performance out in the UK. This is like a universal controller. Basically it takes your general 5-volt sweeping inputs from almost any drive-by-wire throttle pedal, and that will convert it into signal to then drive almost any drive-by-wire throttle body. So I followed the wire diagrams that they provided with the kit basically and the instructions. We're using those diagrams, that information, running that over to the connector in the engine bay for the drive-by-wire. All of that gets power from the interior fuse box, so I went ahead and took that straight from the Festiva wiring diagrams. So this is the factory Festiva fuse box, everything it does. We are no longer using some of these circuits since we deleted a lot of this stuff, so now I can use those for my own circuits instead. So in this case, we're providing power for all of this from our cooling fan fuse, since we're running a different relay for that now. Then for the ECU, we have to have a ton of different inputs and outputs. We're looking at crank position, cam position, flex fuel sensor. We have our wideband O2 controller, which gives us our wideband O2 signal, which has to go both to the ECU and to our custom gauges, which we talked about a bit before, but I'll talk about again on stream here in a bit. Our standard temp sensors for coolant, intake air temp. We're actually going to make some adjustments here because I'm running a different sensor. Even the past 2 days, I've already changed plans for some of these things. So I just made this diagram late last week, and we're already going to delete part of it and remake it. We need clutch switch input for launch control, and then we have our coils. So those are our independent coil on plug coils from Toyota. We've got our new injectors. I'm still using the factory wiring diagram representation for injectors. And then our new fuse box, which we are starting to model over here, which will have a new, bigger, better main relay, followed by all the relays we need to control, like our fuel pump, a relay for our water methanol injection system, which is modeled down here, our cooling fan relay, and then we'll also need to at some point add in our headlight relay, along with a, there's one other relay I needed, actually. I don't recall right now, but we'll get to it, I'm sure. And that's why we're doing this, because there are so many things going on in the engine bay, so many new devices, so many old devices that need some kind of power or some kind of signal. It's easy to lose track. So if you were just going to make a new harness, you're like, well, there's some sensors here and there, it all goes about here, and you start building it, you get lost very quickly trying to figure out where everything actually needs to go. So that's why I'm putting it down on paper first. That way, A, I make sure I'm not forgetting anything. I can sit here and really think through and make sure I have every fuse I need, every relay I need, every connection I need, all the individual connectors and pins themselves that I need to buy so I can crimp those onto wires. We need to make sure we have that ready to go so I'm not scrambling to buy all that stuff online a week later. And reason number 2 we're doing this now is because this way we can go back to diagnose things. So in the future, just like on a Festiva, when you have a problem with your wiring, and you're like, all right, time to pull out the wiring diagram and try to figure out what's broken. If something breaks here, now I have a diagram that I can go back and reference. I'm not trying to guess like 5 years from now, what does this wire go to? I don't remember where I ran this to 5 years ago when I built this thing, and it's all heat shrinked and covered, so I can't just unwrap it and start poking at it. So now I have a diagram that I can use to reference back later, doing diagnostics, any workarounds, etc. So we have some work to do on this diagram, and I'm going to go through and draw some of these stuff brand new live today so you guys can see kind of how I did this if anybody else wants to try doing something like this in the future. And we're also going to look at the rest of our not this, hang on, got a lot of tabs spread out over here. The rest of our sensors. So we have some new sensors that we're adding, like this one for our map sensor and a new one for our oil pressure and temperature combo. All of those need to be wired in correctly, so I'm trying to make sure we have that done ahead of time. So we're going to work on some of that, make sure we have all of our grounds routed correctly, and then at some point we also start needing to measure on the car itself how long these runs are, but we need to really figure out our branch points for the harness. So that's another thing. I don't think we're going to cover that a ton on this video because I'm not ready for that step yet. But in a future video, just to let you guys kind of understand the thought process here, we have to go through and check how long each wire run needs to be and actually start drawing out branch points and stuff. The factory Festiva manual actually does not do this. They don't show you how long the harness runs are or where the branch points are and stuff. But there's other manufacturers, including the companies I've worked for, that's, you know, the standard is you have to show how long a harness is and where it branches out. Because like when you're actually trying to look at a harness and see where something is physically, it really helps to actually see where it branches off, how long that section is. And most of all, we have to really plan ahead here, because if we ever have to take this car apart in the future, we want it to come apart just like it did from the factory. For example, and here's a primary reason why I want to do this now, I actually wired in the wires for power folding mirrors a long time ago into the shell. So I have really rare Mazda GTR power folding mirrors. So just like your factory LX swoopy mirrors that are power adjusting, then you press a button and they actually fold flat up against the car when you park. You press the button again and they unfold to pop back out where they're supposed to be, which is super cool. I actually made my own relay harness for that to make those fit a Festiva. I ran all the wires through the dash, through the doors. I made my own diagram for the future reference for me. Very smart. I was so proud of all that work. And then literally last weekend, we went to go take the dash out, and I realized the way I ran the wires was all through the bars of the dash and then taped it to random spots on the dashboard itself. So I literally couldn't take the dash out because all these wires that I made were in the way. So I had to go through, in that whole fancy harness I built, I had to cut it in half in 2 spots just so I could pull the dash out. If back then I had thought ahead really far, I would have added A, factory connectors at the door, so that way the door harness could separate like it's supposed to and the dash come out, and then B, all the relay controllers I built that were up inside the dash, I would have put those on the dash harness instead of on the body harness. That way when I take the dash out, just like factory, you unplug the plug in the corner, it'd be built into that plug, and the dash comes out as one unit. No cutting or no 10,000 plugs to unplug. But like that sort of stuff, you really have to think ahead to try to get in that mindset of future me. How would you disassemble this? And this is something that OEMs, there's a big challenge for them to do stuff like this. Like when they first, designed the Festiva, they had to think, how are we building this in the factory? How are we taking it back apart? How is the wires going to run through all that to support that, to make it easy to put things together, take things apart without cutting stuff up? So now that I'm building my own harness, I have to be that person. I have to be the one thinking, what order does stuff get removed in? What can you tie the harness to that can stay? What should be quick release? What should be permanent? What should be removable? All this sort of stuff I have to think about now before I start actually building the thing. So there's one thing already, like I just said. So straight away I'm going to have to fix my mirror harness, because I'm looking at it now, because I made a post on the forums back in the day of how I ran all these wires. And I think I might be able to pull it up without breaking everything. Page 6 of my forum post. By the way, if you aren't familiar, this is FordFestiva.com, the actual forums. This is where the Facebook group gets its name. So if you've never been on here, I highly suggest checking it out. The forums are just a huge wealth of knowledge, including my own build thread from many years ago. So this post was made February 2019. So this is almost 6 years ago now that I made this post. So here you can see the factory mirror controller. This is the button you would have clicked to make the mirrors fold in and out. There's the big relay that's needed to control it. As you can see, it's way bigger than the factory Festiva mirror switch, so I had to get creative. I had to build my own harness. That way I could control the mirrors folding with the factory switch. So I designed a way so that instead of being controlled by this button, the mirrors fold normally using this switch, or they adjust with the factory switch and they fold automatically with the key. So I've added a new relay under the dash. You turn the key on, the relay activates and opens the mirrors for you. As soon as you turn the key off, the relay switches and folds mirrors back up. So no manual button, it's all based on the key being on or off. Very cool, I think. So there's not much information on these mirrors out there. So all the diagrams I had were hand drawn in Spanish. I had to do a lot of studying to figure out how that all worked. Here's my wiring. I didn't have fancy automotive wire at the time. I did have this big spool of RGB LED wires, so all the colors are kind of weird because of that. And back then I didn't know how to deconnect pins or crimp my own pins on the thing, so no new pins, no new connectors. It's all factory connectors with the ends cut off and soldered in place. Obviously I would do it different now, and then I wrapped the whole thing with Tesa tape, which is a nice tape and what you do use on the interior, but it means it's a lot bulkier than it should be. I should have used fancy thin flexible heat shrink, but again, this was back in the day. I didn't know any better. Running it all through the door, you can see how bulky that gets in here. Again, I'm trying to tape it up. It got super thick. I didn't put a connector. So there's the factory connector for the dash. I didn't put a new one on here. So all these are just running through that grommet. So if I ever need to remove this grommet, my wires will have to be cut. So that's why I have to redo a lot of this stuff. There's my relay design, the rest of the harness. That's where it goes in the dash. You can see this part goes up to the dash for the relay. That part goes to the switch. This part goes towards the radio for some power, and both this section goes to the door. Here is it all taped up on the harness, so you can see anywhere that this fuzzy tape is. That's where I've added it myself. And obviously that's not going to be a good idea long term, because once again, this harness and this harness are no longer separate. I've taped them together thinking that it would never matter, and now it matters, so oops, my bad. There's a diagram I drew for it, so at least I know enough to go back and correct this, because I gave myself some information. But generally, that's the sort of thing I'm talking about. We need to plan ahead so we don't do this to ourselves building the new harness. So there's a lot to think about. There's a lot to kind of process here, and that's why I want to go through this process, do it all digitally first. That way, like right now, if I make a mistake and mess up something on this harness, I can literally just go click any of these parts and delete them. So I go, oh, this is wrong, delete. Look, now it's gone. I can draw it somewhere else, fixed. That's super easy. Way easier than building a harness, wrapping it, and then having to start over. Because once you heat shrink the whole harness down to fully shrunk, there's really no fixing it, because you're using, like, typically especially on the tips, using glue lined heat shrink. You can't just cut that off and start over. You can't just untape it like a stock harness. It's going to be fully sealed, and that's it, you're done. So we really got to make sure we do it right the first time. Alright, so before I get into some sensor diagram stuff, does anybody in chat have any questions? I think there's 3 or 4 of you in here now, and this will be definitely a good one to post to the group later as a live stream recording. So if anybody wants to know kind of like what I'm doing here, or has any questions about stuff I did in the past I didn't document very well, feel free to leave a comment or chat now and let me know what you think. Let me know if any questions you have. I am going to post a link to this real quick on the page for anybody interested. So bear with me as I post it up for people to check on. If you want to see how I'm building my ECU harness setup, or ask about how we are running the V6T and all the fancy sensors for V2, check out the stream now. And then we add our picture. Voila. All right. Now we'll see if anybody else is interested or has any questions about what we're doing today. All right, so first things first, I am now switching over. I was planning on using the internal map sensor on the ECU, which is this guy right here. So you'd run a vacuum line all the way from your engine to this little port, and that would tell you your boost level and your manifold pressure. That's why it's called MAP. That stands for manifold absolute pressure. But I realized I don't really have a way to send the signal out from this. It only goes to the ECU, doesn't go anywhere else. But our custom gauges that I designed needs its own reference signal to know what the boost pressure is to show me my boost gauge. I will grab real quick. My cord's not very long. For those of you who haven't seen it, either on Facebook or on my YouTube shorts. This is the custom gauge I designed. If I can plug it in. Ta-da! All right, yeah, check that out. So this, hang on, I gotta go back to my preview screen. Never mind the refresh rate there, but this is the gauge I designed. So it's a custom AFR and boost gauge all housed within a factory Game Boy Advance housing, which is very cool. So I designed all these myself with Arduino. I did all the coding myself. A for AFR, B for boost, and there's our B button. So if I hit B for boost, you will see our boost gauge, which shows you max pressure, vacuums, and gives you a live chart of all your pressures, along with a 5-second peak reading. So it takes your peak every 5 seconds and holds it so you can see what you just hit as a peak value for boost. This, however, needs a boost reference signal. So I need to have a different external map sensor plugged in for that to work. Which is why we are switching to a different map sensor. And during my hunt for a map sensor, I found Bosch makes a very high quality and very tidy map IAT combo sensor. So that's IAT is your intake air temperature, which on a boosted car is very important to know. And then of course map being pressure. So this reads both the pressure and the temperature of your intake manifold air. So we're going to replace our intake air temp sensor that we were going to run, which was a little GM universal unit. Instead, we're going to be running this Bosch unit. So I'm going to take him away for now. And then we're going to be running a new wire from the external map sensor section of the ECU, which is pin C8 on the gray connector. And we're going to run that down to the intake air temp / map. This one is a 4-wire sensor, so we need to figure out the wiring diagrams for that sensor. So I'm going to come back. We're going through Ballinger to get this. Ballinger Motorsports, they do a ton of wiring and sensor stuff. And in this case, we bought this sensor. So they have general specs for it, along with the mates for the connector. So I went ahead and bought the connector and pins. I bought the sensor, and then here is all the sensor data. So later on in the ECU, we'll need to calibrate all of this to let our ECU know what voltage is what pressure, etc. And thankfully Ballinger has provided all that. So we're going to want to, first of all, save some of this so that way I have local copies, just in case for some reason Ballinger's website were to ever go down or something along those lines. We want to make sure we have this saved on our own. So we are going to try, can we, close enough. So yeah, we'll try the temperature over resistance chart along with some data points here. Now we can save this in our parts diagram folder. I have it all on Google Drive, so I can access it from any of my computers at once. So this is our Bosch IAT map reference data 1. Go ahead and save that. Scroll up some here. The tolerance expansion data we're not too worried about. That's too fancy for us. We really only need this part. Save that again. Parts diagrams. Reference data 2. Then we need to figure out our pinouts. There we go, connector pin assignment. Tells us all we need to know here on the pins. So we can copy that whole thing. Save that. Same deal. Bosch IAT map. Pin out. And we can put that connector picture in our wiring diagrams. Instead of trying to draw our own, we're just going to use that one right away. Makes it way easier instead of trying to draw our own stuff. So paste that in here. We'll pull that picture back up on my end, so that way I can see what I'm doing here. Actually, put it on the other screen. All right, so connector 1 is ground. We'll go ahead and extend our pin lines up. Make that a black line. Okay. Make a line for pin 2, ending at the same spot. Make a line for pin 3, ending at the same spot. And make a line for pin 4, ending at the same spot. Fantastic. Then we go ahead and group that. So now we can move that around as we want. Okay, pin 1's ground, and I know already that this is my ground line, so this big main line here with the dots on it. Anywhere you see a dot on this wiring diagram is the same as the stock factory festive diagrams. That means there's a joint right there or a splice. So we are splicing in at that point. I just realized I lost my chat again. There it is. War Rally said, you probably said this already, but what ECU and tune software are you going for? All right, yeah, we are running the Dropbear, the new Speeduino Dropbear V2. So it's a full 8-channel independent ECU, fully tunable, customizable, open source Speeduino stuff. It's very nice. V2 even has built-in Wi-Fi and Bluetooth, so you can tune over Wi-Fi and Bluetooth, and it should allow me to connect to my dashboard over Wi-Fi or Bluetooth. And it is way cheaper than any Megasquirt or similar powered ECU. So it's like full 8 channels of ignition, 8 channels of fueling, standard full inputs, outputs, onboard map, Bluetooth, Wi-Fi for $420. And we will be tuning it with TunerStudio, standard open source stuff. All right, so ground is pin 1. That's this wire here, so we are good for ground. Pin 2 on this device is the resistor for temperature, so NTC resistor. That's our temperature resistor. So pin 2 is temp, which is follow our wiring diagram. Well, you know, inlet air sensor. Fantastic. It's already in the right spot. What do you know about that? 3 would be a 5-volt feed, so we can bring that in from the ECU itself. It has a 5-volt reference signal, which is this line here, sensor reference. That's a 5-volt reference line. So we will go ahead and wire that in. 5 volts input. So we need to come down to about here. I'll drop it 2 lines below the ground so don't confuse it with anything else. Then I'll come down same point as the rest. We will add a curve to that to match all the other lines. And since that is a joint right here, we are going to mark the joint with a circle. We know that's a split, not just a crossover. So you see that there's all sorts of spots in the harness where wires cross over each other, like up in here. That's normal. If there's no dot, that means it's not joined there. It's just crossing for drawing purposes. If they cross over each other and they have a dot, like right here, that means it actually is branching from that wire. So that is a splice along that wire. And then pin 4, we have the output signal for our external map sensor. And that is here. So we will draw a new line. Same as before, we want to intersect, cross from here, bring it below our other stack of lines, try to follow the same general space. I should have turned my grid back on, but I think we'll be all right. Looks pretty close to me. I think curve that line. Boom, just like that. Now we have a wiring diagram showing our intake air temp map sensor, just like it's supposed to be. Then I can move that up to here. And then we will edit this in. That's awesome, says Warelli. Thank you. I'm very excited for it. It's gonna be really good when it's all done, I hope. So now we have to mark what sensor we're using. So right here, obviously on the wiring diagram themselves, this just says intake, air temp, and map with a picture of the connector. We don't actually know what connector that is or what sensor this is. To do that, we are going to quickly save this diagram, and then we're going to go into my Google Drive folder. So if I just go to my Google Drive, zoom out a little bit, you'll see here I have Speeduino pinouts, wiring diagram, the other version of it, harness connectors and component list, along with under the parts diagram heading, all sorts of individual diagrams, either from other sensors or from different connectors, so we have all the right images we need. In this case, I want to go back to my component list, since that sensor is one of our components. We need to edit that to make sure it reflects properly the new components that we're using. So over here, we can zoom in, call it 125. Let's go 150 so you guys can see better. Sensors. All right, so you see this whole list of sensors. We are now no longer using this sensor, so I'm going to go ahead and do strike through on those. The throttle position sensor, yes, that's correct. The coolant temp sensor, that is still correct. We are no longer using the Delphi air temp sensor. We are switching to something else for that, so I'm going to strike through there. Crank sensor, we actually now know which sensor we're using. I am going to go find that part number on eBay real quick. I'm going to move that so you guys can't see my entire purchase history in case I might have bought my wife a Christmas gift. Yeah, crank sensor. We're using a Kia sensor, which is that, and it's a junior timer 3-pin connector. Fantastic. Flex fuel pressure sensor. We might actually not end up using it at all because I have a fuel pressure gauge, but I'll leave it for now in case we do use it. So now we have IAT/map combo. The part number for that, according to Ballinger, was I guess they don't give me the Bosch part number, do they? Ah, there it is. It's on the image itself, so we can pull it off of here. That's standard Bosch part number terminology. It goes 0, then 3 sets of 3 numbers. So 281.02.845. We will throw that in here. 028.1002.845. You can see our coolant temp sensor is also Bosch because it follows that nomenclature, and our drive-by-wire, which is over here for controller, same deal, follows that same nomenclature. That's all standard Bosch stuff. The connector for it, mating parts, which is this number from Ballinger. I don't have the stock Bosch number for this, but that's okay. I kind of, oh, no, wait, they do have it. Bosch connector. There it is. So I looked into it as well because it seemed a little pricey compared to their standard connectors. If you look at the GM part number they gave, this part from GM is $138 for just a connector, which is insane. Absolutely insane. Alright, so that should be what we need for our sensor list. There was one other change we made, I believe, wasn't there? Oh, yes, we now have a oil pressure temp combo sensor that we're switching over to, and that came from Low Dollar Motorsports. That one does not actually have a connector, it's just a wire that you add your own connector to. Part number 899403. And they don't actually give a different part number. That's the only part number we get from them. I have a feeling the sensor itself will have a different label on it. Like right here, it might have, yeah, there's a serial number for it. But I trust Low Dollar that they're going to stay in business a while, so we will just use their part number for that. Oil pressure temperature, and that's from LD for Low Dollar Performance. That's their part number, and for that we will probably end up just using Deutsch pins, so I'm not going to add anything to that. Insert another row, keep it all clean. So we do need to add the wiring for that in our wiring diagrams, so we'll go pop back to those for a second. Well, like I said, it's loading the same thing now that it said it's the track car. If you want to do something goofy, I have a diagram to modify the coil and plug for LS coils. I see you're doing Toyota coils. Yeah, so we were doing standard Toyota Echo coils. I actually found a company that makes them in red to match my theme for the black, red, and gold engine bay stuff, which is really nice. LS coils, yeah, you can totally adapt those to do anything. Steven ran LS coils on his B3 project. Speeduino will talk to LS coils, no problem. So no real modification needed. Actually, the LS coils basically run as is with Speeduino. Toyota coils, Volkswagen coils run just fine if you want to use like the Audi R8 red top coils. Tons of options out there. But James Bell over at KA Injection, he makes fantastic coil and plug plates for B series engines. So I would recommend just using his plates and using Toyota coils. They work fantastic. Actually, if I go to James' website, my engine might actually be on there. Ah, not the new version. That's fine. Anyway, so yeah, I would recommend Toyota coils. They're super universal, super well received, very easy to find. Used ones, like good quality OEM used ones for cheap. They are Denso stuff after all. Okay, so we're back on the diagrams now. We need to do our oil temp and pressure. Actually, did I already modify it to have that? Maybe I did. I might be doing better than I thought I was. So let's just double check real quick. We'll go back to our parts diagrams. Bosch IAT, camper face, Game Boy stuff, yada yada. Oil pressure, here it is. Oil pressure and temp. This is from Low Dollar. This is their scaling settings. Looks like we've got red, black, yellow, white, green. And then on my diagram, I have red, black, yellow, white, green. Oh, look at that. I've already done it. And I even decided we're going to be using the Deutsch connector on there. Fantastic. So that is, I think, all of our sensors wired in place. We will do just a little bit of checking around just to confirm that we're good to go here. So looking at the ECU, basically the ECU plugs are set up in a way so that you have inputs on one half of the ECU and outputs on the other. So all of our injector outputs, here's all 4 of them going to injectors, that checks out. Ignition outputs going to our ignition coils, that checks out. Then we have boost output, because in this case we are letting the ECU control our boost pressure using a solenoid valve. And we have that wired in here, boost solenoid valve, 12 volts in, ground control to the ECU, check. What's really cool actually is that we are giving our ECU our speed sensor info. Oh, speed sensor, that's not in our diagram yet. We have to diagram that. I need to figure out which input that needs to go on. I'm guessing it will go on a spare digital input, which looks like we have literally one left. Spare digital 2 is our only input left. So using a speed sensor, since I'm going for a full digital gauge cluster, I can actually skip the entire factory speed cable and instead run a speed sensor that takes the factory speedo output from the transmission and converts it to electrical signal so the ECU knows my speed and then can pass that over to the digital gauge. But because of that, because the ECU will know what speed we're going, we can actually then use math from our speed and our RPM to know what gear we're in, so we can have a gear indicator on our display, and we can do boost by gear. So we can actually control our boost levels by knowing what gear we're in, which is super trick stuff. So for instance, on a Festiva, if you have trouble with traction in first gear or you don't want to blow up your transmission, I can actually tell the ECU that when I'm in first gear, cut the boost in half. So say like 5 psi of boost in first gear. The second I go into second gear, it will know I'm in second gear, and then it can increase the boost up to 8 or 10 psi. And then we can decrease boost in fifth if we're just cruising in fifth and not racing in fifth, or you can make it variable between the two, all sorts of really cool fancy stuff. But because we know our speed, our RPMs, and our boost level, we can now do boost control from the ECU by gear, which is crazy awesome. We're also running our water methanol injector off the ECU. So instead of it just turning the meth injector on and off based on a relay or boost pressure, we can now have a ton of variables set. So if I go in the tuning software, which we'll go into here in a minute, and we go look at our water meth injector, it will actually say, don't even turn on the pump until we hit like a certain temperature on the air intake side, because the whole point of our water meth injection is to help control our intake air temps. So if they're low, then we don't need to be wasting water methanol. We don't need to be wasting injection duty on it if it's already cold. So it won't turn on until the air is too hot, and we're making a certain level of boost since it knows the boost level, and we have a certain amount of throttle being applied since it knows the throttle position, and it won't set it until we have like a certain amount of map data. So boost pressure or intake pressure, or there's one other option you can set for input, which I don't recall off the top of my head. But basically, you can do a whole ton of control side stuff for the methanol injection, since the ECU has all the data of my engine, and it controls the pump. All right, so speaking of a speed sensor, we need to have a speed sensor. And to do that, I need to see what the ECU is allowed to use as far as pinouts for the speed sensor. So we will go over to our Dropbear guide. So this is the Speeduino manual from their wiki. I can go through this and start to try to find what the spare input can be and if we can use it for... What do you know about that? Right away. I said I wanted to possibly use spare digital 2. Here it is, pin A5, spare digital 2, 12 volt or ground switching digital input, can be used for VSS, idle up, etc. So VSS is what we want, that's vehicle speed sensor. So there you go. It says right here, we can use that for VSS. We'll also then need our pinout for our speed sensor itself, which I don't know if I have that yet. Go back to my eBay tab for a second and try to figure out what the part number was for that sensor. Scrolling. Guess it's been a while since I ordered it. Alright, looks like it's the one used for a Hyundai Tiburon, of all things. Hyundai Elantra 07 to 12 2-liter Elantra. So let's try that. Let's try a 2008 Elantra speed sensor diagram. So that's what it looks like. So you can see here, it's got the little threaded part that looks just like the end of a Festiva Speedo cable, but the other end's a plug. So like literally, it's all you do. You screw this in to a physical Speedo gear, like all the Festiva transmissions use, and then it outputs a digital signal. It's very trick stuff. Nope, none of that's very useful. See, these guys actually have a diagram for it. Oh, would you look at that? It's literally cast into the sensor. You know what? Now I remember it. I knew that because I sent a picture of this to Steven for future reference. So there's ground, positive, and S for signal. I believe these are standard 12 volt signals, 12 volt sensors, pardon me. So we should be able to feed just raw 12 volts to that thing. Speedometer, this is not the same one we're using, so I'll have to edit this. That's the one we were going to use, but the connector for that one's kind of hard to find. We wanted the Elantra one, whose OEM part number I actually don't have with me at the moment. But it looks like I use a standard junior timer connector, so it's pins 1, 2, and 3 on a junior timer. So we'll go back to this. Control C that guy. Paste it up here. Plenty of space to do it here, it looks like to me. And then we're going to do a quick little Excel sheet, make our own pinout for it. Unless it's the same as one of these, ground signal, 12 volts. Ground, okay, no, so it's a little bit different. It's ground positive signal. And that's looking at the back of the connector, I believe. Yeah, backside of the connector, 1, 2, 3. So 1 is ground, 2 is feed. Ground, 12 volt feed, signal. Gonna center that. Oh, sorry, you guys can't see what I'm doing. Let's switch over here. I'm just literally putting that exact info into an Excel sheet. I'm gonna give it all borders. Then we're gonna give it thick outside border. And then we're just gonna screen grab that and throw it in our document. There's cleaner ways to do that, but I don't necessarily need a cleaner way. I just need it done. So there we go. Now it's in. Scale it so it's the same size as the other ones we made. Fantastic. We'll put it right next to it. We can feed it a 12 volt signal from our old 12 volt signal here. Then we want no fill on that line. We want to make it a red stroke since it's 12 volt feed. And as always, give it a little curve. Festiva, does that go on the end of the speed cable or straight onto the sensor? That speed sensor goes straight on to the back of the Speedo gear. So that the actual speedometer drive gear itself, that sensor screws right into the back of it. So that would be, hang on, Festiva Speedo drive gear. Ta-da! Yeah, so that screws into the back of this, right here on the back of it. That little spade bit goes right in the back. That'll fit basically any Mazda transmission. So that's E series, F series, G series, manual or auto. It'll fit all of those. It's all standardized. Pablo, can I switch the ECU of a Festiva without having an engine swap? What do you mean? Like, can you run an aftermarket ECU? You can. You can run an aftermarket ECU on any engine, stock or not. You just won't really see any advantages. It's not worth spending money on an aftermarket ECU and then trying to do all the programming to make it work for a stock engine. You won't really gain any power. You might gain a little bit here and there, but not really worth it. So we'll work on G series. So in my case, I'm doing this all on a G. So I have a stock cable Capri G series. We'll be running the speed sensor on that G. We'll also be running a custom crank trigger on that G series, which I will talk about here in a little bit. Once again, we need to draw our splice line. Oop, wrong button. Splice lines. So that's here. Oop, we have a splice. Then back to drawing stuff, we need to go to sensor ground, which we can pull off of this sensor ground. And that needs to be a black line. That needs to have a curve. And we need to mark our splice. And then finally our signal line needs to go to our spare digital in 2. So we will just draw straight across here from spare digital in 2, make it line up with our other lines. Make sure it's vertical. Make it line up with those, just like that, and curve it. Boom. All right, there we go. That's the wiring diagram for our speed sensor added. And we label it. VSS for vehicle speed sensor. That's what it'll be called in all the tuning software, so it's good to leave that same label here. No mistaking what that is. And then for ourselves, we will group these together, so in the future, if I move this around, the label stays with it. Fantastic. All right. Let's save this whole thing again, and let us try to load up our ECU tuning software. So we're using TunerStudio, which is a free tuning software. That's how you tune all Speeduinos and like your standard Megasquirt stuff. I already have a JDMSTIVA V2 project, not connected. Boom. There. Now we have connected the ECU. All these readings aren't real, so no need to worry about those, except for the map sensor. That is real. Actually, it'd be cool. I wonder if I can blow on the map sensor and have it read higher on the map data. Actually, before I look like a goober on camera, can you guys see it? Okay, yeah, so up there, right here in the bottom left corner, that's our engine map sensor. I'm going to see if I can get it to rise. Oh, yeah, look at that. I can blow like 20 kilopascals worth of air. So now we know that sensor works. I think should also be able to pull vacuum on it. Fantastic. One working sensor, done. And that should be the only sensor in this case that works, because no other sensor is hooked up to this. Everything else is just free-floating voltage, current, etc. So let us look at our calibration stuff. So one of the first things I want to do is make sure we have the right setup for our water meth injector. We have it enabled, control mode simple. I don't want to turn on until I'm above 2500 RPM. I should be giving it at least 15, let's call it 20% throttle. Minimum pressure in kPa, probably need to convert that over. I probably don't want to turn on until we're hitting like 4 PSI or so. So we're going to use Google to help us out for a second. 4 PSI is 27 kilopascals. Let's see, 30 kilopascals is 4.3. Let's call it 30 then. or maybe higher. If the default's 120, maybe we should be looking at like 6 pounds of boost. Yeah, let's try 6 pounds of boost. That's 5.8 is 40 kilopascals. Let's go with 40. IATs, let's go for 155. I don't mind injecting a little extra meth at first. We can tune this later when we actually have the car running. This is the important part. Output pin needs to be on the correct pin for our Speeduino. We are using VVT control solenoid 1 for that. Close this out for a second. Come back over here. Refresh this. I actually got confused when I was reading this. I don't know if you guys just saw that. If I go back, I guess not. I was literally texting. So this is how cool it is to be running an ECU that's like really small company, like open source small company. I was able to message the guy that built this ECU yesterday on Facebook Messenger. Like just directly talk to the man who literally invented Speeduino. And I said, hey, I don't know what pin I should be using. And then he said, it was literally here the whole time. He circled it. It was over here on the side in the text on the corner. I was like, my bad. I'm blind. He said, you're not the first to ask that, even though it's in there. He said, you know what? Let me make it easier to read. I'll go change the wiki to have an extra column. And sure enough, just now, I refreshed the website. Boom. He just added a whole new column right here so you know what pin in TunerStudio is equivalent to this pin on the left. That is crazy cool that I was able to ask him that question and literally taking my message and then directly going to change the entire website for the device based on my input. That's insane. So output, VVT stepper C5 is tuner pin or TunerStudio pin 28. So now we can go to our tuning software and I can tell it I need this to be on pin 28. Frequency doesn't matter. Anything above 250 means fully on, which is good. We actually don't want PWM control. We still need a sensor for if the tank is empty. Well, we'll burn that for now. We might be out of inputs on the ECU. Yeah, I don't know if I have any inputs left to run the switch to turn off the methanol injection if the sensor says we are low on fluid. Which is fine. I can instead just run a sensor to the dashboard that turns on a light on that says I'm running low on the methanol. I was hoping to make that automated, but I think I've used too many of my things. Since I have oil pressure and temperature, I have the O2 sensor coming in. Throttle sensor is, I think, a requirement. Anyway, so we can pass that for now. We can probably look at our coolant sensors. Accessories. VSS. Pulses per mile. And let's see what pin that is. We're using Spare Digital 2, which on Dropbear V2 is pin 34. Call Call it a 20% smoothing factor on that. And then we'll have to do a, we'll have to drive at 60 kilometers an hour and auto set our pulses. So we will do that when the car is running. So that's fine. What else do we have? Launch control, we'll set that up later. Thermofan. We still need to set up our coolant temperature sensor. Calibrate pressure sensors. Okay, or the Bosch sensor we're using is a 3-bar sensor, so we're just going to tell it to use a Bosch 3-bar. We'll see if that works later. Coolant temp. That is a standard sensor. Standard 3 trigger sensor, so call that good. Air temp sensor. So now we need that table from our file we picked up earlier. Trying to see here. Data looks a little hard to use. Let's go back here. Oh, yeah, there we go. We want to use that second part of the drawing, the first part. So temperature at -10, our resistance is 9397. It's very close to what they already had here. At 20,500, so what they already got. At 80, 323, also very close to what they already had. So write that to the controller. IO summary. All right, how do I set the first of all, I'll save this tune real quick before I get any further. Oh, that's a lot of stuff. Programmable. So I need to set my programmable inputs to be our oil pressure and oil temperature. Nope. When all else fails, we go to Google. I guess we do add it through here. Let's find oil. Okay, oil pressure. We'll keep it in kPa. Or next we'll try to do bar. We'll keep it in bar. Bar. Input value versus output value, I don't know. Okay, well here's oil pressure protection circuitry options, but they're grayed out, I'm assuming because I don't have oil pressure active. How do I get oil pressure active? Oh, maybe under fuel oil pressure. Duh. On. 0 to 100 psi sensor. And which pin was that on? Go back to our sensor list here. Pressure signal, yellow, that's this wire here. Oil pressure, we're on C2, which is pin A16. Now I just need to find oil temperature. It's all CAN bus side stuff. Alright, well, let's save that for now. I don't want to sit here and mess with it too much until I get some other stuff done, I suppose. We can turn on engine protection based on our oil pressure. And I think the minimums they have set here are probably fine for now. Oh, we want to look at, I want to send a message and see if I am able to use our idle or our TPS sensor input as a different control input. I run out of inputs. And I have one left I wanted to add. I would like to use tank level sensor on the real-high controller. Since I will be using the wire controller, can the TPS pin input be converted to a standard aux input? I imagine it wasn't really on the radar previously, since the TPS input was basically a requirement. Alright, let's see if that's something that they can do for us on Speeduino. That would be awesome. All right, now that we have all this data, we also need to wire our gauge to have boost input here. So let us run that wire real quick. We will be splitting off the boost external map reference signal from this guy. It will need to go all the way over probably run it up and over here. All right, now our custom boost gauge has proper 5-volt reference signal, so it knows when we are in boost and can display it. Super cool stuff. Let's also go ahead then and talk about our digital gauges. Since I mentioned a lot of this is going to be talking to our digital gauge cluster, we might as well pull it up and talk about it because it still needs some work. So this is the Real Dash software. This is meant for aftermarket ECUs so that you can take in data and control them. I'm gonna go ahead and shrink my head a little bit out of the way so you guys can see what's going on here. So what I've done a couple years ago actually is I completely remade the entire stock Festiva TAC cluster in Photoshop / Illustrator. I exported all those files into Real Dash so that way I can make my own dash. So like they have all sorts of like built-in gauges. Don't exit. No, I need gallery. Hang on. Gallery. Free. So here's all sorts of like the stock gauges you would see with this app. These are ones people have designed in the past or just come with the app for free. So you guys have like this, just nice simple flat layout. You've got ones like this, very retro 80s vaporwave type stuff. Ones like this to kind of look like your factory modern gauges, you know, kind of like sweeping on the sides and stuff. All sorts of just general ones, make it really easy to see. If you're willing to pay for it, here's some paid ones that people have made in the past. So this is like the modern BMW one. This is like the modern Corvette style one somebody's made a copy of. This is like a copy of the S2000 dash, which is already a digital dash, which is cool to see them kind of redo the LCD style display in here. Very basic data engineering type one, like a system monitor looking thing from a PC. All sorts of cool stuff. Somebody remade an F40 dash that works. So with that in mind, I set out to rebuild the stock Festiva dash with extras. So what I wanted to do is be able to give it something like a boost gauge, give it a higher RPM gauge, give it AFR gauge, stuff like that. All sorts of little extra bonuses, basically. And so that's what I've done. I have this old school 8-bit style font. So now we have a boost gauge that looks like the stock 80s like 323 GTX style gauge. So it looks like an old digital gauge. a sweeping AFR gauge, which isn't quite lined up like it's supposed to be. I was trying to make some changes to it. That's going to look like an old 80s bar gauge. Our Speedo, same deal, digital 80s gauge with like old 80s text on it. But the difference is that now your speedometer goes to 160 instead of this factory 85. The coolant temp and fuel gauge are almost identical stock, except now the logo for the fuel gauge will actually blink to let you know when you have low fuel. The factory shift light from the Carby cars, the early 88, 89 cars that have the shift light in the dash, I've incorporated the factory shift light, but now it actually works like a real shift light, so it will be off and not fully off. It's kind of hard to see probably on YouTube. If you look really close, there's actually a ton of icons in here that are true black, and the background is kind of off black. So just like a real Festiva dash, when the lights are off, you can still tell where they are if you look close. So if you look close, you can still see where the shift light is, but now it functions like a real shift light, where you have the orange as in shifting too early, green when you're in the correct shift range, so you see it turns green as you start to hit your shift points, and then red if you're starting to over-rev past your shift point. The turbo gauge is also interactive, so the icon for it, you'll see right now it's orange, so normally it's just a yellow icon. It will turn orange when you start to overboost, which I have set to 12 psi, and then if you go over, I think, 14 psi, it will start to blink rapidly to let you know you are way overboosting. So the icon, once again, also acts as a secondary warning gauge. Up top, we have a standard layout. We have turn signal left and right, high beams, cluster lights. So like modern cars will actually tell you when the high beams are on and when your headlights are on. This will tell you now when your headlights are on, since I don't have the buzzer anymore, since I'm taking out the TAC cluster. I hope to still add a buzzer in the wiring itself later, but until then, we have the icon. We have our parking brake icon. And soon, I'll be adding even more gauges. So we're hoping to have our like a indicator for our methanol injection tanks, so you know when it's empty. We'll have a gauge for oil pressure. It will look just like the factory coolant gauge, except it'll have a pressure icon next to it and operate the same way. Then I'm thinking another factory gauge for oil temperature, perhaps, or possibly for something else. But basically, we'll have 4 of the standard style gauge: fuel, coolant, oil pressure, plus one more. I'm not sure exactly which one I'm going to go with yet. All this will be running on a very ultra-wide display, which I actually have here. I can pull it out real quick. So all of this is going to get displayed, cord's too short, on this. It's an ultra-wide, Ultra HD IPS LCD screen. So the factory Festiva gauge fits very nicely right here in the center of this, and gives us some extra space, like an extra 1.5 inches on each end to put extra gauges on top of. So things like what we have here with our AFR, or our bonus gauges for the pressures and everything like I was talking about earlier, all sorts of fun stuff. However, to get Real Dash to actually see the inputs, like for it to know when my turn signal light is on, is a ton of work. You have to convert like analog 12-volt signals into CAN. So I've scrapped the idea of doing all that in the middle with the screen. Instead, I'll be using a 3D printed overlay. And if I go on YouTube real quick, surely one of these tabs I can find and go to YouTube. We go to YouTube real quick. Phew! Oh, bless me. Jeez. So I've been following along with this project that this one guy's been working on. This guy is building his own digital dash for his Nissan 300ZX Z31. I won't play the audio just yet, but if we scroll through here, he's got an old video. This is the factory digital dash for the Nissan 300ZX, which is, you know, very retro cool. You can see it's got your oil pressure, battery level, all that on little bars here. The standard, the cool old VFD display, tachometer, an old VFD display. It's very cool, very retro, but kind of outdated. And also he talks about this, where these fluorescent tubes, when they burn out, there's really no way to source these again. Once they're gone, they're gone. You have to buy a whole new, very expensive cluster. So instead, he is using this digital dashboard from, I believe it's a Ford F-150, Ford Escape, Ford Explorer, something along those lines. It's all CAN controlled. It's just basically these two big round screens. But from the factory, Ford, actually where these numbers are, this is a plastic ring, a little plastic bezel that goes all around the outside of the thing. So instead of displaying everything on a screen, Ford gives it some more depth by adding this big plastic overlay. So all these little small lights here, all these numbers, this is actually a big plastic ring that sits on top of the screen. So it wastes some screen real estate, but gives you real LEDs. So he actually took that apart, so you can see there, that's what I'm talking about. There's the overlay bit. And behind it are some LEDs. So there is, hang on, I'll let it play for a second. So here he custom printed this circuit board with these LEDs built into the back end, all these little icons and stuff. So these don't need, he's still using a controller, but in theory, you don't need a controller to light these little lights up. You could have these lights light up with a standard 12-volt signal, which is what the Festiva does. To turn on your indicator lights and turn on your bright light or the check engine light, those are just standard 12-volt bulbs behind the screen or behind a plate. So you can just take the stock Festiva wiring, power a 12-volt LED like this, and then put an overlay over it. And then he 3D printed his own custom overlay like so. So here we go. It's all 3D printed, LEDs stuck inside of it. So instead of using the Ford one, he printed his own, and then he modifies the screen underneath to kind of match that print. So there's the whole screen that Ford's using. Then he designed this entire circuit board. You put that on top, you program it, etc., etc. I'll go ahead and skip to the end a little bit here. You turn on the car, boom. You have a full LED light sequence. Then all the center part is LCD. The outside is a real physical print with physical LEDs in it. After I saw that, I thought, holy cow, that's absolutely brilliant, and I'm going to try to copy some of that on my design here. So we will be doing something very similar on my dashboard. So instead of it being all screen, instead we'll have our gauges all be digital, and then all the icons in the top and bottom corners will be a 3D printed overlay that physically sits on top of the screen, which helps A, keep the brightness good, so that way all your icons and your numbers stay nice and bright, but B, it gives some depth to the cluster and keeps it looking real. Because sometimes when you have just a raw screen in your dash and only a screen, it kind of looks off. Like you can tell there's a big square screen in the dash. It does not have like the natural curves and stuff that your stock cluster would. So if I go like to the digital dash install, if I go to images, you'll see, here we go. This is a typical aftermarket install right here. So I think that's an Miata right there. You can see, nope, I didn't want to play a video. I just want to see the icon. Anyway, you can probably get the idea from looking at this. It's just a big square screen and then a 3D printed block off plate with two other gauges kind of stuck in there. So you can tell that doesn't belong. It doesn't look like it's part of the car. Same thing, like if we go to this one, that's where the factory gauge cluster used to sit. Instead, they have the hull tack just sitting on a 3D printed bezel, and instead of like icons, it's just little bare LEDs poking through, which again, like for a race car and stuff, that's totally fine. But I really want this to look factory. I want it to look super integrated. So I think doing it the way that that guy did with his cluster, where he took the screen style one and then he actually added the overlay to it, that's going to make it look like a real factory gauge. It's going to make it look like it belongs. So that's what I'm working on here pretty soon. And I have a lot of work to do because doing all this in Real Dash, this probably took me 3 weeks to get it to this point. Because like every single thing, like every single icon needs adjusted. This is actually 3 icons stacked on top of each other to make it do the cool blink effect. The shift light to change 3 different colors depending on your RPM, with a whole set of rules that I have to create and code into it. So it's a lot of work to get something to this point. So that's when I keep talking about digital dash, that's what I mean. I'm working on that. So all of this stuff in the ECU is going to end up communicating to all of that stuff on the dashboard side here pretty soon. Again, that's all stuff I am super excited for. Put my head back up here for a second. Oh, I feel like I've been doing nothing but talking, so at some point I'm going to sore throat doing all this. But that's kind of what we're looking at. I wanted to do a quick video about it and kind of show you guys the process here, what all I'm doing before I start actually physically building the process here at the end of the month. Basically, I think starting 26th of December, going all the way to the 5th, is going to be a lot of the actual building of the harness, and we'll be streaming all of that and showing you guys all the crimping and wiring and running of cable runs we're doing. Oh, it is so much work. It's a ton of work. I definitely am doing too much on this project, but I think the end result's going to be super worth it. So I think we only got a couple people left in here. If there's any questions, anybody wants to see anything else in detail, let me know for sure. I'd love to talk about this and show you guys anything else you want to see with more detail. But I wanted to at least get this out there and kind of give you guys some of the detail of what's going on. I know people have a lot of questions about stuff like this. I hope to make a lot of this documentation available. So like I'll compile all this when I'm done and have it available for you guys to see and download and really view on your own to try to help you guys. Obviously, I can't make this a step-by-step guide. There's just way too much work in here for me to guide you through like step-by-step how I built this exact thing. But I hope this gives a big enough overview that you guys can follow along a bit and at least have a good understanding of the goal and what exactly we're doing here when it comes time to build this in real life here in a couple weeks. All right, I don't see any other questions currently. So as always, thank you guys so much for watching. I'll be streaming again later this week and definitely a ton next week and the coming weeks after that. So stay tuned for those. If you have any other questions or want to check it out, then please feel free. As always, thanks for watching, and I hope to see you next time. See ya. Oh no, can I not end my own stream?